my name's Jess. I'm going to take you on a virtual tour of the ANU Science Precinct. I'm a Masters of Environmental Science student at the Fenner School of Environment and Society. So this is Una, this big cool orb sculpture, and it sits right in the middle of the ANU Science Precinct, and it has more than 9,000 holes in it, which represent the night sky. And if we look inside, it's pretty amazing. You guys should come down and check it out. It's really beautiful. So, here she is. Hey guys, so now we're in the CPAS building, which is the Centre for Public Awareness in Science, and we're about to go talk to Dr. Maren McKinnon in the iconic green couch room. So here she is, Dr. Maren McKinnon.
Hi, welcome to CPAS. So this is the green couch room. This is one of our main teaching spaces, and this is actually an upgraded green couch.
Oh, sweet.
Yeah, the original green couch sadly went on to other pastures last year after being with us since the centre started. But typically this room, we use it a lot, so people do sit on the couch during lectures, but quite often a lot of our teaching, we're up, we're doing stuff, working in small groups. Everything that we do here is very practically oriented and real world. So
yeah.
any of our courses, really, come along, come join us.
What is CPAS all about?
CPAS is all about training scientists or people in engineering, maths, medicine, any discipline really, anywhere where you have to communicate something complex and you need to make it interesting, engaging to a range of audiences. We have the tools, the experience, the expertise to help you do that.
Exactly. So it's a field that is relevant to every science field, so it's really important.
Absolutely, every discipline. I mean, it's one of the key learning outcomes for any university student, that ability to communicate.
Exactly.
It's a core professional skill, and we have, like a lot of our courses and the way that we do our teaching and our research here, it's all very much real world oriented, often based on stuff that we've learnt when we were out working and what we wished we knew. But definitely it's all about equipping you with the ability to go out, have a career and make a difference.
Yeah, awesome. Well, thanks so much for meeting us.
Pleasure.
Have a look at the iconic green couch. And cool, thanks. All right, hey guys, here we are at MSI, the Mathematical Sciences Institute. This is the Hannah Newman building, which is quite new and super cool because all up the side of the building, it's covered in binary code and waiting for you guys to figure out what it means. So let's go check out MSI. Hey guys, so we're inside MSI with Dr. Asilata Papa, here she is, and she's going to tell us a little bit about what they do here at MSI and what she does.
Right, so thank you. So I'm a mathematician, research mathematician here at the MSI, that's the Mathematical Sciences Institute, and we're in Mandy Gordon's office, and this is beautiful maths art created by some of our former and current students in the department. So this is all mathematical art based on graph theory and fractals and homological algebra and that kind of cool stuff. So some of that is what I do, and some of that is new to me too. But yeah, I'm an algebraist and geometer here. So
wow, cool. So what kind of stuff do you work on?
I work on studying symmetries of various shapes in various dimensions. So that's my thing.
All right, so here we are in one of the seminar rooms, which is one of the teaching spaces, and we are looking at one of the chalkboards. So, Asilata, can you tell us a little bit about these chalkboards?
Yeah, sure. So this is the math seminar room, and it's got these lovely big chalkboards, but it also has these sliding whiteboards. And the reason for that is that we share the space with the computer science building, and the mathematicians prefer the chalkboards, but the computer scientists prefer the whiteboards.
Do you know why that is?
I don't know. I just, as a mathematician, I prefer chalkboards, and I think that's because it's somehow more visceral to write with a chalk, you know, and you could kind of just put more energy into it. So that's my reason.
Cool.
I don't know what the actual reason is.
Yeah, awesome.
Yeah, so in this beautiful seminar room we have our usual seminars and meetings and big classes and things like that. So, and there's a nice view of the outdoors.
It is pretty good. Awesome. All right, well, thanks so much for showing us around.
Sure, thank you.
And we'll see you then.
Bye.
Cool, thank you. Hey guys, here we are in the Forestry building, which is part of the Fenner School of Environment and Society. And here we are with Stampy, who is our mascot. So this is the forestry courtyard, which is where I like to chill out and have lunch. And it's kind of cool because in this little space, we have 3 of the only known living fossil trees. So one of them is the Wallamai pine, this guy here. And there's only one place that it lives in the wild, and it's secret, top secret location, somewhere in the Blue Mountains, but we've got one growing here. And the second living fossil tree is the dawn redwood, which is a little bit underwhelming right now because it's deciduous. And the third one is ginkgo biloba over here. Hey guys, here we are in the research school of biology, where lots of really important biology research is happening, and I have to whisper, but I'll show you around. Very cool. Cool, so thanks for joining me on the tour, guys. I hope you enjoyed and hope to see you here sometime. So I'm going to pass you on now to Atul.
Hey everyone, my name's Atul. I am a postgrad student here at the ANU, and I'm currently with Australia's very own legendary astronomer, Professor
Doctor, yeah, we're all the same. Yes, so we're here at Mount Stromlo Observatory to see all the cool space things we got going on. And it's one of the hubs of space activity in the Southern Hemisphere. In fact, I'll even extend it beyond the Australian borders.
Ooh, all right then. You guys ready?
Let's go see what we have. So this is called the Advanced Instrumentation Technology Center. And this is where we build telescopes, satellites, and get things ready for space. Okay. And in fact, we actually had to make sure we can come in today because just last week they were preparing an instrument to go into space next month. So it's been a busy time in this facility sending things into space. So we're gonna go down here and we're gonna take a sneak peek from above. And this is what we call the Space Simulation Facility. So this gets things ready for space. And we have our extra large wombat because it looks like a giant wombat.
Yeah.
And we're gonna go inside and see there, but that's kind of where the magic happens. Now this is what we call a space simulation facility. This simulates the conditions of space. So we can pump out all the air and it's like we're in space.
Yeah.
So if you were inside when it was operating, which we don't do,
you would actually be in a vacuum.
You would be in the vacuum of space. You would need a spacesuit to survive.
Both vacuum and temperature ranges.
Yeah, what temperatures can we get down to?
Plus 150 to minus 150.
Yeah, so 100, because we always...
Minus 150 degrees Celsius.
Yeah. And this is actually one of the interesting things, is we think space is always cold, but space is also hot. So depending on going around the Earth, for 45 minutes when you're away from the sun, it's minus 100 degrees Celsius. And then you get in front of the sun, and it's 150 degrees Celsius.
Okay.
So things in space go freezing, boiling, freezing, boiling, freezing, boiling. You know, space is a very interdisciplinary area. So, you know, if you like physics and biology, it's astrobiology. Yeah. It's all about chemistry and
but
math.
you can actually do physics and law, and there's actually a field that's emerging.
And
by the time that I graduate or something.
There's literally a desperate need of space lawyers.
Really?
Yes. Like
nice, if you're listening.
If you become a space lawyer, you'll get a job as soon as you graduate.
Right.
Agencies, companies, they all need them. And until a few years ago, there was 6. Like literally 6.
6 in the world.
6 in the world in Australia. Yeah. So it's a really interesting thing. We were talking about our clock earlier. So this is the clock.
This was the clock. The
that,
clock that kept time in Australia for decades.
That's right, and it was one of them. And until we moved to atomic time. So you know, it's a beautifully orchestrated clock that we.
So did people frequently just come in here, look at their watch, correct it?
It was in a different room.
Room.
Over here is a copy of Brian Schmidt's Nobel Prize.
Okay.
So Brian Schmidt won the Nobel Prize in 2011 for discovering the universe was accelerating. So we've known since the 20s the universe was expanding. What Brian set out to do is to measure how slow the universe was growing, because we actually thought the universe would stop and then collapse in on itself.
The Big Crunch.
The Big Crunch, that's right. Well, Brian found the wrong answer. He actually found that instead of slowing down, it's speeding up.
Yeah.
Now, it wasn't wrong, it was right. It was just not what we expected. And so now we know that the universe has something called dark energy, which makes up literally 70% of everything. And that's what Brian led a team to discover. So he won the Nobel Prize in 2011. So this is his real diploma. And this isn't the real medal, this is the real fake medal.
The real fake medal.
You get 2 real fake medals. He has one here in one of his office.
Okay.
But the real medal that he got, he actually gave to Questacon. So if you visit Canberra and go to Questacon, there's a display on the Nobel Prize, and that is the real one, worth a lot of money.
Okay. Well, to any students interested in just science in general, not necessarily being a student,
right.
just have a visit there.
Yeah, Questacon is great.
Yeah, I love Questacon.
Yeah, and it's it is a cool thing that he did.
Okay.
One of the traditions up here at Mount Stromlo is in the 2003 bushfires, most of the observatory is destroyed, including this building. In the downstairs area over there, the library contained all of the theses for all the students who have been here.
Oh, okay.
So when it burnt, all of the theses for 80 years were destroyed. The tradition now is when we graduate, when a student graduates, you burn a copy of your thesis and you add some of the communal ashes to it. So it's the past,
in memory of
that's right. So here's some of the past knowledge of past theses that have come through it. So we all just add just a little bit of it. It's therapeutic as well.
I can imagine it being therapeutic for a PhD student,
especially
4 years,
especially all the corrected versions. But it's also keeping in line the tradition which happened with all of that history that went up in the fires.
Okay.
So this yellow building is what we call the Commonwealth Solar Observatory. So this was one of the original buildings built back in 1928. So in fact, Mount Stromlo was established in 1911, 2 years before Canberra, to study the sun. Because this follows that there was a big global project to see how the sun was active, solar storms, all those sorts of things.
I'm currently in the Science Precinct area. I'm currently in the Science Teaching Building, which is where first year, second year, and third year undergrads are expected to do their labs. I'm currently joined right now with Dr. Tristan Ricky,
Thank
Professor.
you. Doctor, come on, give me a few years.
And you're also a coordinator as well for teaching?
So yeah, basically look after second and third year students here.
Okay.
Oversee that as well as teaching a bit into first year.
Okay. So we also have a professional here with us as well to make sure I don't explode anything. So Tristan, do you mind just giving me just a bit of an outline of what first years can expect, first year chemistry students can expect to the ANU?
So we have both lectures and labs, and we have quite a good focus on lab skills, because as a chemist, a lot of the stuff that we're going to do practically is lab work.
Yeah.
It also helps us understand the theory. So once a week, every day of the week, students will come into our first year lab and do a lab for 3 hours in the afternoon, learning both practical and theoretical skills. This is a pretty new building. It was just built in 2013, purpose built for our undergraduate teaching here. So it's a really amazing facility.
Okay. And how do you think this compares to, let's say, other kind of chemistry places in Australia?
So I want to, protect my words a bit so I don't get in trouble, but of all the universities I've seen, this is the best equipped undergraduate labs.
Okay.
And I have seen a few. It's not just new, it's just really well designed to have. We have 100 students in here in a regular year.
Yep.
And they're able to, they work in pairs, work on their own, got all the equipment that they need, and a really great support staff having that ready for them for when they arrive.
All right. Well, why don't we have a look at the second year labs then?
They're much more exciting.
Much more exciting. All right then.
So this is second year lab, which
Yes.
does both synthetic chemistry as well as biological chemistry. You might see in the background our lovely people in green who help set up the lab.
Do you mind if I introduce you, Avis?
Yeah, that's fine.
I've known
Just
Avis.
don't fill my mess.
Okay, no, this is not a mess. This is cool science.
Wait till you
stuff
see
right now.
undergrads in there, then it's a mess.
Hi.
Hey everyone, I've known Avis for 3 years now. She has been absolutely lovely. If you need help in the lab, feel free to just ask her. So you said that there was synthetic and biological chemistry going on here. So what, do you run bio coursework in here as well?
I guess the proper answer is sort of. So as a research school of chemistry, we're sort of at the forefront of what the meaning of chemistry is. And chemistry isn't just about, making molecules, but there's also a lot of what we call chemical biology, where we use proteins and bacteria and that sort of stuff in our chemistry as well. So
They become the molecular machines that can run reactions.
So we have a really broad definition of chemistry here at RSC. So both, I mean, some other places might call it biology. For us, it's definitely part of chemistry.
Okay. All right, Theresa, any advice that you would want to give to someone who's potentially interested in chemistry?
Okay.
Not 100% sure, but you know, they like blowing things up in their high school labs.
So I think the main thing I really always want to make sure students know is that if you want to do chemistry here at ANU, you have to have done it in year 12.
Okay.
So please, if you're interested in chemistry, do make sure you do it year 11 and 12. You are welcome to contact us for any sort of planning advice that we can offer.
They genuinely do offer that. So you can just email us, you can email the chemistry school directly.
So
if you have the passion, we're more than happy to accommodate.
And especially since we normally do this an open day face-to-face, video is the best thing we can do. But definitely have chemistry. If you're not sure what you want to do, my advice is try it all. What I really love about the way ANU operates is that we give students the choice. So yes, you might choose a science degree, but that doesn't mean that you have to choose chemistry right away. You can do a bit of chemistry, biology, physics, maths, psychology, all of these different things, and sort of make it sort of become more specialized as you go up in years, but you're not committing as a 17, 18-year-old to the rest of your life. Also offer like double degrees. You can do science and arts, science, law, and really have that flexibility, which is I think what ANU really offers really well.
So I'm here right now at the Wood Library, which is located within the Fenner School for Environment and Society. The Fenner School does a lot of very interesting research around how Australia can, I guess, improve on policy, research, collaboration to overall improve our sustainability and our footprint in Australia. So I'm currently in this Wood Library that was established in the early 1920s. And it sounds weird when I talk about a wood library. It is literally a library of understanding the different types of wood. This is literally like a half-a-minute walk away from your lecture theatre within the Fenner School. So if you're interested in coming here, literally just knock on the door and it'll be fine. I think it's probably worth mentioning I have done some really cool stuff with the Fenner School. I did a research project under Professor Jeanette Lindsay, who at the time was one of the directors or like deputy director of the Fenner School, and she was absolutely lovely because I was looking at changing patterns in the climate. Well, actually, I was pretty much looking at the climate of Maria, and as part of that project, I actually went down to Maria, to the south coast, to present my findings to the local farmers, the local officials, and volunteers, which was an amazing experience. So highly recommend doing research projects or getting yourself out there because ANU will give you that opportunity. Hey everyone, I'm currently in the Australian Plant Phenomics Institute facilities, and I'm joined by Dr. Poire. Am I pronouncing that correctly?
Perfectly, yes.
Okay. So what are we here doing, Dr. Poire?
So here at the Australian Plant Phenomics facility, we are providing a research infrastructure to grow and measure plants to enable scientists to answer questions about how plants should evolve in the next 10, 20 years to provide Australia with food and energy and ensure that it will be continuing to grow.
Okay. Would you like to give us a tour?
Yes, I'd love to.
Yeah. Oh, here's the sign. We're officially at the Australian Plant Phenomics facility.
The engine room gets a bit noisy from here.
Okay. Hopefully the sound is okay. Oh. Okay, look, with this sound it means the machines are on, meaning that they are working and they're functioning.
Sound. Quiet is not good here.
For us to get filming, maybe not, but for us to actually talk about it, you know that it's actually working.
So here we have a scientist.
Ooh, okay. Hello there.
Oh, hey guys.
Hello there. What's your name?
Rochelle.
Rochelle?
Yeah,
Charbel?
Yeah.
Doctor, professor? Doctor? What are you doing right now?
So we're sampling plants with overexpressed for the primary carboxylase and C4 synthesis.
So we're here at the Research School of Earth Sciences where we're very lucky to have a guided tour today. Would you be able to tell us a little bit more about the Research School of Earth Sciences?
Absolutely. These 8 buildings here in this complex make up the Research School of Earth Sciences, where we study the physics and chemistry of planet Earth. So everything from the core to the mantle and the crust and the atmosphere and the oceans, all of that gets worked on here within the school. And we'll take you around to a few laboratories to show you a little bit about it.
This area here is called the Shrimp Lab, which stands for
sensitive, high-resolution ion microprobe. And they were very smart when they invented this equipment in the 1980s to come up with a really neat acronym like SHRIMP. And this stuff is quite famous worldwide in the earth sciences. We originally made SHRIMP 1. This one here is SHRIMP 2, SHRIMP 3, and this is the newest SHRIMP SI. And they each do slightly different isotopic analyses of material. So for instance, the oldest material on Earth, the 4.2 billion-year-old zircons from Western Australia, were analyzed on this machine here. So we can determine how old the rock is, we can determine a lot of really interesting things by taking a little bit of it, putting it inside of the chamber, plating it in the beam, and sending it on a big magnet to measure the isotopic composition of it. So these three machines are running pretty much 24 hours a day, every day of the year, and many of our graduate students spend endless hours here.
Okay, so here we are in the GFD labs. This is the Geophysical Fluid Dynamics. As you can probably tell by the name, we're interested in the fluids on Earth. One of the obvious fluids on Earth is an ocean. There's also atmospheres, rivers and lakes. But then we also are interested in the more slower but flowing fluids, such as ice and glaciers, or lava, or mantle in the inner Earth. One of the most fundamental features of fluids on Earth is that they're affected by the Earth's background rotation. So one of the neat things that we have in this lab is actually two of these rotating tables that we use to model Earth's Coriolis force.
Hey everyone, I'm here at the ANU Makerspace, joined with the founder and I guess the mastermind of the Makerspace, John Debs. JD, we can call him, right?
Yep.
So can you just tell us a bit more about how this actually started?
Yeah. So I guess the space was really born originally in the School of Physics, Research School of Physics, from a philosophy that people learn by doing. So if you think about where how we start to understand our world, we often start building things and tinkering and going, oh, how does this work? And I mean, certainly as a scientist, that's sort of the perspective that I take with my education. And so we wanted a place where we could do that, but we wanted everyone from the campus to be able to interact with one another as well.
Yeah.
And as we started to grow it, what we really learned was that makerspaces they're kind of like community workshops, but they're really about that community first.
Yes.
At the end of March and closed campus pretty much to everyone, we'd already started asking a question of could we do something to help community need due to the pandemic, and in particular there was a lot of talk around sort of community-made PPE, particularly the face shields, because they're quite I guess low-lying fruit. They're just a piece of plastic with some foam and some elastic.
But that's something that a healthcare professional can pretty much be using in the field.
They need
right?
them a lot, right?
Yeah.
And because Australia has been fortunate in terms of the numbers and how things turned out, but because of what's happening around the world, the global supply chains are strained. And so what we looked into was was there a demand, and could we do it? And so it was really important to answer that question first. There was a demand. We contacted actually one of our alum from the Makerspace, who's a doctor at the hospital and sort of works in ACT Health, and he told us there was a demand. We actually got someone reached out from the Sydney Health District, the Southeast Sydney Health District, and so very quickly we sort of went from, within a few days, the university gave us access to come back onto campus, approval to come back on and start making stuff. We did some really quick and dirty prototypes in here using the laser cutter, both to cut jigs out, but also to cut the first pieces of film.
Yes.
A lot of people talked about 3D printing being used in PPE manufacture, but it takes a long time to 3D print things typically.
Yes.
It can be a really fantastic tool, but something like a piece of film like this, that can be laser cut in a matter of seconds.
Okay.
And so you can pump them out much faster.
So how many did you make all in all?
So once we got the process down and we ordered materials, the smallest order of foam we could get, this foam was pre-cut, was 17,000 units, and so we made 17,000. Look, I think the thing that's really great about the 3D printers is that we often joke that people come for the 3D printers and then stay for the laser cutter.
Okay. All right, guys. Thanks so much for watching. Hope you had a great time. Look forward to seeing you at ANU next year.